Does the function x of t equals a sine omega t describe all possible harmonic motion for appropriate choices of a and omega? And the answer is no. There are other things, other choices that can be made, or maybe you could even say that there are other ways of setting up harmonic motion this function wouldn't necessarily describe. I would say it depends on how picky you want to be, though. So what I mean by this is like another choice. If somebody said, well, I want to describe a harmonic motion with the function a cosine omega t. So they're a real rebel, I guess. They said, I see you're using sine, but I don't like that. I'm going to use cosine. And that's fine. That also describes simple harmonic motion. The only difference is the starting point. So when I said it's a matter of how picky you want to be, if you're picky about where the motion starts, then the function a sine omega t might not be good enough for all cases, because as we saw with the graph earlier, sine at t equals 0 starts at 0. If you have a harmonic motion that t equals 0 starts somewhere else, then a sine omega t is not going to be good enough for that. If you want it to start at maximum amplitude, something like a cosine omega t, or more generally, if you want to have the freedom to match whatever starting point you like in your setup, you would have to use a function, and this is one possibility. There's different ways of doing this, like you could use cosine instead, but you'd need to add some kind of phase. And I have to admit, I always forget, are you supposed to add or subtract the phase in this thing? I'm gonna subtract the phase here this time, and maybe let me know later if I did that wrong, because sometimes I add it, and it's really a matter of like how you want to define your phase. And if you're picky about things like initial conditions and matching that, then that becomes a whole mathematical thing to look at. But it turns out for describing physical harmonic motion, we may not always be interested in that. So in that sense, the function we have does not really mathematically, with exactness, describe all possible harmonic motion with any possible choice of starting conditions. As a physicist, though, I like to say, well, what if I just change where I define t equals 0 to be? If I'm allowed to do that, then it turns out a sine omega t is good enough for all situations. So what may be not good enough in math class is good enough for a physicist. I think I've said my answer long enough here. Let's see what the answer to the slide says. It says no, more general function with a phase, and that's, I think, look, that's the one I chose. I guess amazingly, I guess the same sign is what's in there. That's the one that would be needed. That phase winds up accounting for arbitrary initial conditions.